All right. So we're going to finish up the Lecture 8 notebook. Again, if you have any questions about Lab 3 or Homework 3, feel free to pull them up, and we'll look at those questions after we finish up Lecture 8. So again, we have to run this first cell to make sure we have all the necessary libraries. And we're going to go down to past bar charts, all the way back down to numerical distributions. So this is kind of the last topic, and it's actually pretty complicated. And the reason why is because, number one, we're talking about distributions. And distributions are how we look at unique values and the frequency of how many times they come up. And when you have something that's numerical, you may have values that differ very slightly. So for example, if we look over here, each of these movies have a different amount of gross income. So what happens if we looked at all possible movies, not just the biggest one that year? Well, then that would be a lot more variety, and we wouldn't want to use a bar chart for that, because then we'd have a bar for each, not only each movie, but a slightly different bar for how much money it made. So to fix this, instead of looking at a slightly different variety of bars, what we're going to do is we're going to count the number of values within a specific range. And this process is actually called binning. So you can think about it as just getting a group of values in a specific range. And once we have those values in a specific range, we're going to count all possible values in that group. And so this is our idea of binning. So let me just go ahead and give you a definition of binning. Let's say insert above. So one definition. So again, binning is just a count of the number of values that lie within a specific range. Okay. And so in our next example, we're going to bin a group of movies based on their age. And then we're going to represent that using a new graph here. So let's just go ahead and run our first line of code here. And so we have that our top movies is not defined. Okay. So I think we need to scroll back up, because I realized we did something last time and I don't think it's still here. Let's go back up. Studios. Okay, so here's the top movies. So let's go ahead and run this line of code again, and we'll pull this line of code. All right, so now we have our top movies table defined, and we can go back down. All right, so now let's run this. So we run top movies. This is the chart that we're looking at. And so what we've done to top movies is we added this extra age column here. But we need to adjust this column a little bit, since what we're saying is take the year 2019 and subtract our movies column from it, and that's going to give us the age of each movie. So for example, Star Wars originally came out in 1977. So 2019 minus 1977 is 42. So let's change this to 2021, since we're in the year 2021. And we'll update this, and we'll see all the age columns are going to update. All right. So let's go down to binning here. And again, we're just going to put different movies in specific groups, depending on a range of values. So this is just going to tell us the min and max age. The oldest movie in our list is 100 years old. The youngest movie is 4 years old. And let's go ahead and make a few different bands. So What we're doing here is, again, we're making our bins. So here is our bins. Let me all right, so here's our bins. And if we look at these values here, what this is saying is we want all the values between 0 and 5. So that's our first bin. So we'll say bin 1 is equal to movies between the age 0 and 5, but not including 5. Then our next bin is going to be movies from 5 to 10 years old. So this is bin 2. So this is 5 to 10. And this pattern is going to repeat. So we'll just do, let's say 2 more. So our next bin is 10 to 15. Our next bin is 15 to 25, and then finally 25 to 40. And so the pattern is going to repeat, but let's go ahead and write down a few more. So bin 3 is 10 to 15, and bin number 4 is going to be the values 15 to 25. Okay, so our bin's always going to include the smaller value, but it's not going to include this larger value. All right. So now that we have our bins, what we're going to go ahead and do is we want to go ahead and count the number of movies in each specific bin. So for example, in bin number 1, we want the number of movies that are 0 to 5 years old. In bin 2, we'll get all the movies between 5 and 10 years old. And to do this, we're going to use this new method down here called bin. So let's just run this line of code, and it's going to update this table over here. Oh, sorry. Let me try and exit it up. Okay. So now that we have this new table updated here, what this is telling us is that in our first bin, we have 3 movies between 0 and 5 years old. And between 5 and 10 years old, we have 25 movies. Between 10 and 15, we have 18 movies, so on and so forth. And notice we don't have any movies that are 100 years old or older because there was no movies 100 years ago. So now that we know what this data is, let's go back and review this new method that we just introduced called bin. So this bin method, so let me first say that bin, and remember last time we introduced group, these are very similar, but they have slightly different functions. So we'll go over the definition of bin, and then we'll see how they're different. So again, anytime you're working with bin, you're going to be applying this method to a table. So here we have bin, and our first entry is going to be our column name, and this is going to indicate what values we're going to be working with. So what values do we want to put in specific bins here? And then our second argument is going to be actually our bins. So we say bins is equal to whatever your bins array is. So the array that makes bins. And so the output of this function, sorry, the output of this method is going to give you a new table. And in one column, it gives you the actual bins. So it tells you the range of values. We say in one column. So in a column, you have bins. And in your, oops, in your other new column, you're going to have the count of the number of items that go into each bin. So for example, again, in this bin here, so the values between 25 and 40, we have 42 movies that are that old. So the other column is the count of each bin. Okay. And so the reason why we're doing this is because we're going to use this information, again, to visualize our data using histograms. But for now, let's go ahead and we'll be using this number real fast. And all this is doing okay, so what this is doing is this is just giving us the number of movies in our data set. So overall, there's 200 movies here. So this is going to be useful in a little bit. The only other thing that maybe I'd want to add about this bins function is that you can change what the bins are. So for example, we use this make array to make a specific set of bins that were not equal to each other, but we could have easily made bins that were equal to each other. So here's an example of, again, we're making, say, bins from age 0 to 100, but this time we're cutting them up into 4 different groups. So the bins are going to be 0 to 25, 25 to 50, 50 to 75, and 75 to 100, because we have this step increase here of 25. So let's say bin 1 is 0 to 25, bin 2 is 25 to 50, bin 3 is 50 to 75, and bin 4 is 75 to 100. So if you run this line of code, you can see this reflected in this table here. You have 3 bins, or you have 4 bins over here. So this is bin 1, this is bin 2, bin 3, bin 4. And then you're actually always going to have this last bin here that doesn't contain anything. Okay. And you could play around with this. So maybe you want only movies that are 20 years old. And let's say you wanted to just look at the number of movies each 2 years. And so we rearrange our bin count here. All right. So finally, we're going to see how to display distribution of numerical values. And again, this is going to be very much like a bar chart. The only difference now is that the size of our bars are going to be different. And so the area of our bars represents the percentage of individuals for each bin. And so let's actually compute the percentage of each bin. And so again, we're going to use my bins, which is, it says it's not defined. You defined it up here though. So yeah. Oh, I see. Sorry, I was looking at the wrong thing. Okay, so here we have my bins. And now that we have this, let's go ahead and compute the size of each bin. So for example, we want to see proportionally how many movies are 5 to 10 years old, how many movies are 10 to 17 years old, and so on and so forth. So just a real quick goal real fast. Find the percentage of movies in each bin. And so we want to find the percentage of movies. Number one, again, we have to find the total number of movies. So step one, find the total number of movies. And then step two, we're going to take our age column. So take age count and divide this by the total number of movies. All right. So we actually already found the total number of movies, but maybe let's look at a different way of doing this. So the table that we were working with was, again, my movies. So let's make a copy of this down here. And so we just want the total count of these movies every day. So what we can do is we can just go ahead and say top movies num rows. And this gives us 200. So we have 200 movies in this given table here. And so we'll just say that this is equal to num, so number of movies. So now we have step two, and let's look at our other table that we had. Where is it? Okay, so this is our other table. Let's go up. Yeah. Okay, bin data. Let's use bin data. Forward. Okay, so here we are. And again, let's insert another cell and look at this. And so we want to take each bin and the number of movies in each bin and divide it by the total number of movies here. So we want to find this array. So this is going to be then bin underscore data column. And then our column name is age count. And let's see what we get out. So we get this array of values, which correspond to this array right here. Okay. So now that we have this information, we can actually go ahead and find the percentage of movies in each bin. So this is a goal. So let's go ahead and take this array and just divide it by the number of movies. And let's see what we get out. So we get this array of values. It's a little bit hard to read. So let's just add it to this table here. So we're going to say now, we're going to call this an array. So we'll call this array just percentage, I guess. Percentage. And now let's add this to our bin table. So we're going to have bin data where column. And we're going to say, call this just percentage, so percent. And now let's add our array. And let's see, this is not doing anything. So what's going on here? Let's add this to bin data. And then, okay, so it says we're getting an error here. Table has no attribute of where column. Ah, I see. Sorry. I made a mistake. The method isn't called where column, it's called with column. With columns. All right. And so now we see here we have overall percentages, but this is not quite right It's a little hard to read, so let's multiply this by, I think, 100%. And now see, okay, so that looks a little better. So what this is telling us, for example, that movies that are between 40 and 65 years old make up 26.5% of all the movies overall. And so movies that are 5 to 10 years old are 12% of the overall percentage of movies. Okay. And so now with that in mind, let's go ahead and run the next cell, which is telling us about our histogram. And so what we see here is, again, number one, the size of this bin is indicating that, the size of the bin of your data is equal to the area of the percentage of the overall data. So for example, let's see here. Let's go back to Yeah, okay. So again, I guess what I'm trying to say is that the area of these bins are equal to the percentage of the overall data. So for example, our bigger bins, for example, 40 to 65 years old, indicate that the width of our bar is larger than our smaller bins. So for example, this first bin is from 0 to 5 years old. And so this is a smaller bin. Okay. So lastly, the only thing that we want to do is let's go ahead and point out what's happening in this histogram here. So number one, again, when we're looking at a histogram, we're looking at a table. Okay, so in this table, we have our method is called hist, and we have, again, 3 arguments. We have the column of values that we'll be inputting. We have our bins. So again, the bins are going to be made with an array. So our array of bins. And then finally, our last bit of information is just units, and this is just percentage per unit. So this is unit. This is equal to our percentage of unit. Okay. So so that's how we, again, graph numerical values. Usually you're going to use a bin. Last time we went over categorical variables. And so let's stop here with the lecture and look at the question.